Hello, and welcome to today's lesson on understanding right triangles. Hopefully you remember from our last lesson that all three interior angles of a triangle add to 180 degrees, and that the area of a triangle is 1/2 times its base times its height. So what is it that makes right triangles so special? First of all, they will always have exactly one 90-degree angle, and the other two angles will be acute angles. And for right triangles, instead of calling them sides, we call them legs. So the area of a right triangle is just 1/2 times one leg times the other leg. And then the third side of a right triangle is called the hypotenuse. It is always the longest side of the triangle, and it is always across from the 90-degree angle. So let's take a look at one of the biggest theorems in all of mathematics and the most important one for right triangles, which is the Pythagorean theorem, which tells us that if we take one of the shorter sides and square it, and the other shorter side and square it, and we add those two numbers together, then the result is what we would get if we squared the hypotenuse. So let's take a look at a visual proof of the Pythagorean theorem, because if you haven't learned by now, you'll soon find that mathematicians need to prove everything. So you see that we've drawn a square on the outside of one side to represent leg 1 squared, and we've drawn a square on the outside of leg 2 to represent leg 2 squared. And what we're going to find, hopefully, is that when we take these two areas and add them together, we are going to get the area of the big square, which represents the hypotenuse squared. So let's see what happens. You'll note that just by changing the angle of the rectangle, it doesn't actually change its area. And what we find is, indeed, those two areas added together give us this biggest area. So let's take a look at some Pythagorean triplets. These are positive integers that fit the Pythagorean theorem. So one example is 3, 4, 5. Let's verify that this actually fits the Pythagorean theorem. So here we've got our 3, 4, 5 triangle, and here we've got the Pythagorean theorem. Now all we have to do is plug in our numbers. So 3 squared plus 4 squared should equal 5 squared. Does it? Well, we get 9 plus 16, which does in fact equal 25. This is a true statement. So what are some other Pythagorean triplets? 5, 12, 13 is also one. So let's take a minute and verify this. So take about a half a minute and try to do this one on your own, and then we'll go through it on the screen. So here again we have the Pythagorean theorem, and here we have the numbers plugged in. So 5 squared plus 12 squared should equal 13 squared, and we find that 25 plus 44 does equal 169. So 5, 12, 13 is another Pythagorean triplet. One last one is 7, 24, 25, and I'm going to leave this as an exercise for you to try on your own later. So one last thing that we need to talk about are special right triangles. So Pythagorean triplets are special in that they all have integer sides, but special right triangles are special because of the angles in the triangle. So our first one is the 45, 45, 90 triangle. And so the sides are always going to be in this particular ratio. Two of the sides will be equal because we know that the sides opposite equal angles in a triangle are equal lengths. And the hypotenuse is always going to be whatever the side length is times the square root of 2. So let's take a look at an example. Here we have our 45, 45, 90 triangle. Let's say we know that one of the sides is 3. then we also know that the other side is 3. And what is the hypotenuse? It must be 3 times root 2. The other special right triangle is the 30, 60, 90 right triangle. So the smallest side is always across from the 30 degrees, and the hypotenuse is always twice that side. The side across from the 60 degrees is the smallest side times root 3. So let's take a look at an example. Here's our 30, 60, 90 triangle. Let's say we know the hypotenuse is 10. That tells us that since it's twice the smallest side must be 5, and the remaining side must be 5 times root 3. So that's everything for right triangles for today. I'm leaving you with a bonus question. I'd like you to follow this YouTube link and look at a video clip from The Wizard of Oz in which the Scarecrow gets his brain. He attempts to recite the Pythagorean theorem, but he makes some mistakes. So for bonus points, what did the Scarecrow say that was wrong? Email me and I will let you know whether you're correct. I hope you enjoyed today's lesson, and I'll see you next time when we talk about quadrilaterals. Special thanks goes to Louis Tallman of the Metropolitan State College of Denver, who created the animation of the Pythagorean theorem proof.